Okay, hello. Welcome to the FRQ of today. Today we're going to see if we can figure out the 2010 number 4. And so this is, I think, a nice little challenging problem here. And so I don't know if this sort of thing is going to be on the AP exam this year, but we'll chat about that momentarily. But let's see if we can figure this out. So an automobile company wants to learn about the customer satisfaction among the owners of 5 specific car models. Large sale volumes have been recorded for 3 of the models, but the other 2 models were recently introduced, so their sales volumes are smaller. The number of new cars sold in the last 6 months for each of the models is shown in the table below. And so for car model A, there was that many new cars sold, for B and so forth. So a total of 297,354 cars of these 5 models by this company. All right, the company can obtain a list of all the individuals who purchased new cars in the last 6 months for each of the 5 models shown in the table. The company wants to sample 2,000 of these owners. Part A, for simple random samples of 2,000 new car owners, what is the expected number of owners of Model E and the standard deviation of the number of owners of Model E? Part B, when selecting a simple random sample of 2,000 new car owners, how likely is it that fewer than 12 owners of Model E would be included in the sample? Justify your answer. In Part C, the company is concerned that a simple random sample of 2,000 owners would include fewer than 12 owners of Model D or fewer than 12 owners of Model E. Briefly describe a sampling method for randomly selected 2,000 owners that will ensure at least 12 owners will be selected for each of the 5 car models. So if you want to pause this one and give it a shot, that would be great. Okay, so like I said, now this is actually a binomial situation and a binomial problem, but I hesitate to do this one because it's possible certainly this could be on the exam this year, but I'm really not anticipating this. And this is the sort of problem for some people. You just do what you can to get 1 or 2 points out of it. But anyway, so let's look at this. So for Part A, it says if you select 2,000 cars, how many what's the expected number that own E? Well, in the population, what you could realize is, well, so the probability of E in the population is just going to be 23 over 297,354. And that is approximately equal to 0.007 So there's like 0.8% that it's going to happen. All right. So therefore, all right, if you select 2,000 of them, you're expecting in essence this proportion to have Model E, and so that is what I did right here. So for the mean, it asked for the mean and the standard deviation. So for the mean, I just said N times P. And so that's 2,000 times that proportion, and so it's 15.62 approximately. So that, and don't round it to the nearest integer at this point. So you would just report it that. Now, what about the standard deviation? And what you would have to recognize in this situation, this is a binomial situation. It's a success-failure thing in Part A, where it's either they bought E or they didn't. There's our proportion, and our fixed number of trials is 2,000. And so, and in regards to a binomial situation, our mean is N times P, according to the formula sheet here, and our standard deviation is the square root of N times P times 1 minus P. And there's our probability for a specific value, but you would have to recognize this as a binomial situation. So therefore, our standard deviation for Part A is our sigma is the square root of N times P times 1 minus P, so it's 2,000 times P, which is that number there, times 1 minus P, which is about 3.94. So that's the mean and standard deviation. All right, and so then it says when selecting a simple random sample of 2,000, how likely is it that you get fewer than 12 owners? Well, and so we'll use binomial CDF on that. All right, so what's the probability you get fewer than 12? That's just binomial CDF. CDF means cumulative. What's the probability of 11 or fewer successes? And so there's your N, there's your P, and theirs is 11. So we're expecting there to be like 15 or 16, but to just get 11. So that the probability of that is 0.146. And so it's not extremely likely to happen, but it's certainly very plausible that it can happen. All right, and so the next thing is that they don't want to have any of the car models have less than 12 in their sample. So how could we do a sampling method? How could we do a sampling method that ensures we'll have at least 12? And what we could do is we could take and make sure and get at least 12 from each group, and that's what we call a stratified sample. So there's different ways that you could sort of describe this. You basically just had to say, you have to get at least 12 from each of the models and then randomly select those numbers. Now, if you wanted to get really complete about it, you didn't have to do this, but you did have to say that we could get a stratified model and get at least 12 of each model. And then if you wanted to be really complete, you could prorate it by the proportion in each model. Like A, so in the population, the proportion that got A is 1,100 or 112,338 divided by 297.54. And so that's what I did right here. Is so and so there's the proportion of A in the population. If I multiply it by 2,000, so I got 755.6. All right. Now the reason, and so I would get 755. The reason I rounded down here is I rounded up on these here. And it actually, when you added up these, they added up to 2001. And so I had to take the one that was closest to rounding down and round it down. All right. So anyway, but I prorated for each of the different car types. In the population, that is the proportion that got B. And so I want my sample to be the same proportionally. And so in my sample, these are the numbers. I'm getting 560 from C, 22 from D, and that should be over 297,354, and then 16 from E. And then I just said, so for Model A, you'd randomly select 755 cars from the 112,338 of Type A. Similarly, randomly select 647 from Type B, and 560 from C, 22 of D, and 16 of E. So now, like I said, you didn't have to state it as completely as I did. You just had to say you do a stratified sample and make sure and get at least 12 from each group. So therefore, from each group, randomly select from, at least 12 is what you basically had to say there. So, okay, that's it. Like I said, not a lot of people did really well in this particular problem that year, but, that's okay. So and if you can get all this right, then that's good. I think the hardest part was recognizing that it was binomial, but anyway, but thanks for watching the video. Send me any questions that you might have, and then tomorrow we're going to have one that is, I feel, definitely going to be the sort of thing that you're going to see in the exam this year. So anyway, all right, see y'all again soon.